Lesson 1.7, Are they the same? Defining congruence. In this lesson, we'll determine whether two figures are congruent just by looking, and explain whether congruent corresponding sides is enough information to determine if polygons are congruent. In class today, we started our discussion of congruence by looking at all of these figures where we have a person's hands are mirror images of each other, and we're asked to select all of the left hands. So if I wanted to find all of the left hands, the ones that look like this, it looks like this left hand is palm down, and the thumb is coming off to the right of the hand. So let's find all the other ones that are left hands, that are palm down. Looks like this one, if I turn my head a little bit or rotate my head a little bit, it's hand down with the thumb coming out to the right. I'll select that one. The one on the bottom, same thing. I can select. This is a left hand. As I'm moving over here, this one doesn't look quite the same. It looks like this face down hand has the thumb coming out to the other side. So I'm not going to choose that one. This one, if I turn my head just so, looks like the thumb is coming out to the right. This one, the thumb's coming out to the left, and this one, the thumb's coming out to the left. So if I just wanted to select the left hands, the ones that were all the same as this left hand, then I've highlighted them in blue here. So I've selected all the left hands just as a way to get started talking about things that are figures that are the same. What we didn't get to in that last screen is a better discussion of what same means. We got all those left hands figured out, but let's take a look at these figures and decide which pairs contain figures that are the same. And what does that really mean? As I'm looking at these, I can make a guess about which ones are the same, but I think I'm gonna be better off if I switch to a different screen so that we can use transparent paper to talk about their sameness. So let me just switch there now. So here we have the same figures, and earlier I sketched each of the shapes onto some transparent paper to help me make my decision. So I'm looking at figure A, and I'm thinking, gosh, that kind of looks like I could just rotate it and it would wind up like this figure on the right. But to be sure, I'm going to go ahead and try it. So there's my figure on the left outlined. Let me see if I can just rotate it around. Yep, I sure can. It fits perfectly on top of the other one. So just by rotating figure A, I can see that these are really the same shape. One's just rotated around. If I look at figure B, though, I can tell without the transparent paper that one of these figures is bigger than the other. So we can use the transparent paper if we want to, but just flip this over. Yeah, it's real clear that one figure is bigger than the other, so I'm not going to say those are the same. Figure C, it kind of looks like a reflection, and I can be sure, I can be sure by trying it out. There's the figure on the left. Let me see if I can flip my paper over and get it to map onto the figure on the right. Yep, looks like those are the same. With D, again, I can just tell by looking that those are not the same. This one is flatter than the one on the left, but I could always use transparent paper to verify that. If I tried to just translate that over, clearly they're not the same shape. It doesn't fit perfectly on top of the other one. This one's a little confusing. I'm not sure what I can do to make this figure into that one. I might need a series of transformations. So let me try this out. Let me see if this will work. I'm going to try, let's see. Let me try rotating it. All right, I rotated it 90 degrees clockwise, and I got close, but I need this little part to be on the top. So if I rotate it first and then reflect it, it looks like that'll make it the same. So I'm going to say that E has two figures that are the same. And F, I don't have to use my transparent paper. This one has two triangles and this one has two triangles, but clearly they're not the same shape. There's no series of translations or rotations or reflections that'll make the figure on the left map onto the figure on the right. So with that said, let's go back to here and decide which pairs contain figures that are the same. Well, we decided we could rotate those figures in A, and they would be the same. We could reflect C, and it would be the same. And we could rotate and reflect E, and the left figure would fit perfectly on top of the right one. But there was something wrong with these others in the right column. Let's talk a little bit more about why this first one, why B wasn't the same. In class, we took a closer look at this and talked about one reason someone might say that these figures are the same, and one reason that someone might say these figures are not the same. Let's start with one reason someone might say these figures are the same. Well, they're kind of the same. They have this tall part in the middle, and then an extra little piece coming out of one side on the bottom, and an extra little piece coming out on the opposite side on the top. So I could say that. One reason one might say these figures is the same is they have a tall middle and an extra piece off of the bottom and the opposite side of the top. But one reason someone might say these figures are not the same is they're not the same size. The one on the left is bigger than the one on the right. Typing too fast. So I wouldn't say that these were the same. Let's go ahead and bring this home by talking about the words that we're going to be using in the next few lessons: congruent and not congruent. We're going to replace what we've been saying, same, the figures are the same, with figures are congruent. And figures are congruent if one of them will fit perfectly on top of the other through a series of transformations, reflections, rotations, and translations. So let's talk about each of these cards and determine whether they're congruent or not congruent. We'll start with this one on the left, these two chevrons. It looks to me like if I took this figure on the left and reflected it over a line of symmetry down the middle, I'd get this figure on the right. They look like the same size and shape, just reflections of each other. So I'm going to say that they're the same. Nope, I'm going to say that they're congruent. Let's look at this second figure. It looks like two rectangles with opposite corners kind of snipped off. And I think if I took this one on the left and rotated it about 45 degrees and slid it over, or translated it to the right, I'd have this figure on the right. So they look to be the same size and shape. I'm going to say that they're congruent. Let's take a look at this figure. Now, I'm just eyeballing this, but the figure on the left is clearly bigger than the figure on the right. I could flip it over. I could reflect it so that it's, they're facing the same way, but there's no way around the fact that one's bigger than the other. One won't map perfectly onto the other, so I'm going to say that they're not the same. Nope, not congruent. I'm going to get that to fit in there. There we go. Let's look at these figures. If I take the figure on the left and rotate it about 90 degrees counterclockwise, it looks like it's going to become this figure on the right. Rotate it and slide it over. So I'm going to say that these two are congruent. And these last two, it looks like the figure on the left is much larger than the figure on the right. I might be able to reflect and rotate to get them pointing the same way, but the figure on the left is just bigger. So I'm going to say they're not exactly the same. They're not congruent. So whether something is congruent and not congruent is what we're really trying to get at in the next few lessons. Let's go into a little bit more detail about what we can say about figures that are congruent and what we can't say about figures that are congruent. Just because they have some things in common doesn't mean that they're congruent. And that's what this next slide is getting to. So this graph shows 6 polyominoes. And we're going to look at what's the same about all of them and what's different. Well, there's a few things that are the same. I'm going to get something to write with here and point out the fact that if I look at their area, how much space this pink space covers up, in figure A, it looks like it covers up 1 square, let me get a pen, 1 square, 2 squares, 3 squares, 4 squares, 5 squares, and then this little bump out on the top. It covers 6 square units. And the same is true of all of them. I could look at figure B here. 1, 2, 3, 4, 5, and then 6 on the side. And figure C looks a little bit different, but it still covers 6 square units. The same is true of all of them. 5 in the long part, and then 1 little bump out. One more time. 1, 2, 3, 4, 5, 6 square units. So they all have the same area. Let's take a look at their perimeter. So if I were an ant crawling around the outside of this figure, let's start with figure A. I'm going to start at this corner. Let's count up how many units of perimeter there are here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the perimeter of this one is 14. So this one has 14 units around. Writing with the mouse. Let's take a figure C here. We're just going to move to there and look at what its perimeter is. I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It has a perimeter of 14 as well. So if we look at figure A and figure C, they both have the same area, 6 square units. They both have the same perimeter, 14 units. So is that enough to say that they're the same? Well, no. One way they're the same is they have an area of 6 square units and perimeter of 14 units. But the polyominoes are different in that the extra square that comes off the side either appears towards the edge of the long piece or in the middle of that long piece. And you can see that figure A has that extra little square more to one side, where figure C has that extra little square more in the middle. So I don't think we can say they're the same, even though they have the same area and the same perimeter. That. So all the polyominoes that are actually congruent, well, those are only the ones that I could rotate or reflect or translate to get something that was the same shape as figure A. Now, as I'm looking from A to B, I could just rotate that up. I'm sorry, I could reflect it across a line of symmetry here, not rotate it, sorry about that, and get B. But there's nothing I could do to A to make that little extra piece, switch over to the middle. If I look at A and D, I could reflect A over a line of symmetry right down the middle. So those are congruent. A and F are not congruent because, again, that extra little piece is in a different spot. There's no transformation that I can do that will map A onto F. And with E, I could rotate figure A counterclockwise by 90 degrees and get it to E. So just because they all have the same perimeter and they all have the same area doesn't mean they're congruent. They have to have the same shape. So to pull all this together, how can you determine if two figures are congruent? Well, if there is a series of what we call rigid transformations, and those are the translations, rotations, and reflections that we've been talking about. If there's a series of rigid transformations that maps one figure onto the other, then they are congruent. So to finish up, if I asked, are figures A and B congruent? I would have to ask myself, is there any way to turn figure A and make it the same as figure B? Now I'm going to look at how wide they are at their skinniest and at their fattest. Figure A from top to bottom looks like it's about 2 units wide, and same for figure B at its skinniest point. But when I look at the long part, it looks like figure A doesn't quite reach over to this edge. So that's not quite 4 units. But in figure B, it does. Top to bottom is 4 units. So I'm going to say that A and B are not congruent. And we'll finish up by just saying why. Figure B is longer across its long side, is longer across the long side than figure A. If you've been absent, then you can finish up with the assignment that's assigned today by filling out the blank class notes in your notebook, and the key is right here linked up. Finish up on pages 28 and 29 in your workbook. Make sure you try every problem, check your work using the answer key linked up here, and indicate whether your answers are correct or incorrect as you're checking. So in this lesson, we determined whether two figures were congruent just by looking, and explained whether congruent corresponding sides is enough information to determine if polygons are congruent.